Okay, for what we're going to be looking into, we're going to make the transition from the real number system to the complex number system. And now, different books can use different letters, but for complex numbers, okay, the dominant one is the letter I. And now in the real number system, real numbers do not allow for the square roots of or even roots of negative numbers. Now we have for the complex numbers, okay, there is an allowance. And now for the letter I, this is going to be in reference to the square root of -1. And if I square out I goes to I squared, and the square of the square root of -1 goes to -1. And just a bit of a sampling of reducing complex numbers in terms of the letter I. Let's say that if you have the square root of the negative of a perfect square, like in the case of the square root of -16, and if I look at taking what we have here, okay, so I can say that I have the square root of 16 times the square root of -1. Square root of 16 is going to be at 4. And once again, we have square root of -1 is in reference to I. So we have for the square root of -16, that is going to end up at 4i. And let's say that if I have another opposite sign of a perfect square number with -100, and if I reduce in terms of the letter I, so I had the square root of -100 is a complex number, and putting in terms of the variable I, square root of 100 is at 10. Square root of -1 is at I. So the square root of -100 is at 10i. Now, for the square root of -27, 27 is not a perfect square number, but it is nonetheless a value that can be reduced in the square root. And for the square root of 27, that is reducible to the square root of 9 times the square root of 3. And the square root of -1 becomes I. And as a reduced radical, we can say we have 3 times the square root of 3 times I. And since I does not go inside the radical, you could also write this, and to safeguard I from seeming to appear to go underneath the radical, only the square root of 3, we can write this as 3i times the square root of 3. Now another number that, like 27, is the multiple of a perfect square, even though it is not a perfect square in its own right. We have, in the case of 98, now we have the square root of -98. And if we factor out gradually, okay, we have the square root of 98 times the square root of -1. Now, in terms of reduction, now the highest perfect square divisible into 98 is going to be 49. So we have square root of 49 times the square root of 2. And we have with the square root of -1, that goes to I. And in terms of the reduction, we can say, in effect, that we have 7 times the square root of 2 times I. And you can also put the I out in front of the radical, so we can say we have 7i times the square root of 2. Now, for the square root of -63, we can say we have square root of 63 times the square root of -1. And like 27 and 98, 63 can be reduced. And so we have with 63, highest perfect square that is divisible into 63 is going to be at 9. And so we can say we have 3 times the square root of 7 times I, or 3i times the square root of 7. Now, let's say that for what we have in the case of complex numbers, if we're looking at interacting, and there is a rule of thumb, okay, whenever you're interacting with complex numbers. Okay, now when multiplying or dividing complex numbers, okay, you want to go ahead and factor out the I first. I'll give you just some quick instances here. And let's say that if we have the multiplication, and we'll say that we have the square root of -9 times, okay, the square root of -4. Now, what you're going to do here is that you're not going to take the square root of -9 times -4. Again, you're going to factor out I first of all. So for what we have in the setup, we have for the square root of -9, we can say we have square root of 9 times I. For the square root of -4, I have the square root of 4 times I. Square root of 9i, this will go to 3i. Square root of 4i, this will go to 2i. 3 times 2 is 6. I times I becomes I squared. And guess what? Going back, we have with I squared, that is equal to -1. So we have 6 times -1. And so for the product of the square root of -9 and the square root of -4, this will go to -6. And let's say that if we have as another case, if I have the square root of -10 times the square root of -5. So I can factor out the letter I. Square root of -10, that's the square root of 10i. Square root of -5, okay, that will be the square root of 5 times I. And multiplying together, we have the square root of 50, I squared. Square root of 50. 50 is not a perfect square, but this can be reduced. I squared goes to -1. And we have square root of 25 is 5 times the square root of 2. Then we have times -1. And so for what we have in effect, multiplying everything together, so we're going to end up with the output. This will be the negative of 5 times the square root of 2. And we have as yet another instance. Okay, and we'll cross over to the operation of division. And let's say that if we had the square root of -80 divided by the square root of 5. Again, in the case of working with complex numbers, whether you're working with multiplication or division, go ahead and factor out the I first. So we have the square root of -80, so this will be the square root of 80 times I. And we have over the square root of 5. And for the square root of 80, highest perfect square that is divisible into 80 is going to be 16. So we can say we have the square root of 16 times the square root of 5 times I. And we have all over the square root of 5. And here we can have square roots of 5 to cancel out. And for what we have in this particular instance, square root of 16 is 4. And we have times I. And so that is going to be the reduction in this particular regard. Okay, and now just case here that we have regarding complex numbers, and we have here again just laying the foundation. Once again, we have I is equal to the square root of -1. I squared is equal to -1, and we have with complex numbers. Now the standard form of a complex number is going to be A plus BI. And we'll say that if we have writing in terms of the standard form, and we have, let's see, if we take as examples here, and let's say that we write in standard form, or in this case, A plus BI form. And we'll say that we have in our operations, we'll say the first case, we'll say we have 3 plus the square root of -4, and we have plus the square root of 5 minus the square root of -64. Okay, so we have complex numbers in the mix. And let's say that if I go ahead and translate out the square roots of -4 and -64, so we have in the rewrite, we're going to have 3 plus 2i quantity. And for 5 minus the square root of -64, we have 5 minus 8i. And removing the parentheses, we have 3 plus 2i plus 5 minus 8i. And combining the real coefficients, so we have 3 plus 5 plus, in the complex numbers, we have 2i minus 8i. So we have altogether 3 plus 5 is 8. 2i minus 8i, this will become -6i. So we have 8 minus 6i. Now, and let's say that if we have multiplying complex numbers together, and we'll say that we have the square root of 5 plus the square root of 7i, and we have times the quantity of the square root of 5 minus the square root of 7 times I. So if we look at multiplying together, now we'll do this one gradually. So we have the square root of 5 times itself, that is going to be the first product, and we have with the outside products, okay, so you have square root of 5 times the negative of the square root of 7 times I. And then we have for the inside product, we have the square root of 7i times the square root of 5. And for what we have in the case of the last of the products, okay, so we have the square root of 7i times the negative of the square root of 7 times I. So we have with the first product, okay, this is going to be reducible, so we have the square root of 25, and then we have the negative of the square root of 35 times I. Next product, we have square root of 7 times the square root of 5, that would be square root of 35, and we have I attached, and then we have positive times the negative is a negative, and we have square root of 49, I squared. Now, we have with the I terms of first degree in the middle. Okay, so these will cancel out. And we have for the square root of 25, that goes to 5. And we have on the far right, square root of 49 is 7. I squared is going to be at -1. So you have 5 minus -7, and of course negative times the negative is going to be a positive. So we have for the end result here, we have 5 plus 7 to end up at 12. Okay, so we have in the end result, okay, you have 12, and that could also be written, if we're putting in A plus BI form, you can see we have 12 plus 0i.